So this is additional information. If you take away one of the hydrogen just now, because you know that hydrocarbon is carbon and hydrogen. So if you take one of the hydrogen away and you substitute with hydrogen, right? So it will change name already, right? It will change name. So if you replace with hydrogen, we call it halogen substitution. This is just a name, chemical name, right? Okay. You substitute with hydrogen, you take away one of the hydrogen, you replace with other items. It's called halogen substitution. This your for your info lah. This one for your info. When you read lah. When you read. This one for your info ni. This one for your info ah. Additional info. So basically, if it's second family, alkane, you know that it's double bond, right? So the double bond, if you break one of the bond, you have one more structure. For example, this one. You break the double bond on the left-hand side, means that it's able to pack more cars, pack two more cars between the carbon. Okay, so means you break away this double bond, carbon have one more parking space to park the two chlorine, for example. Okay, the rest of it. It's just your additional info for you. Okay. Okay, so you need to answer this question in your lab report. You need to answer why vegetable oil is an unsaturated fat in your lab report. Okay, the rest you read. Okay, so to summarize, all hydrocarbon means C and H combination. They will undergo combustion reaction. Combustion reaction, you will get only two product, same product. You'll get CO2 and water. Okay, so the first one, summarize. Hydrocarbon, you burn it, you'll get water and CO2. Alkane, it will go through substitution. However, the one with double bond, triple bond, alkylates, undergo additional, means it goes substitution. You can break the bond, then you can add additional member inside it. Yeah. Okay, we go for the last section of this chapter. It's called aromatic hydrocarbon, where you will see this ring structure, benzene. You don't need to memorize. You'll be given in the test. This one, you substitute with a ring structure. Okay. Benzene. Benzene can be found in most of the perfume or something that you can smell good. Right? We have covered what is resonance structure. Again, right? So what is the difference between the left structure and right structure is the coordinate of the double bond and single bond. As you can see here, right? The switch location of the double bond and single bond. Okay. Commonly, you see in chemical reaction or chemical books is this ring structure. You see this ring structure, it's called benzene. Benzene equivalent to, if you see this one, you need to count the number of carbon. You need to add 1, 2, 3, 4, 5, 6, 6 carbon, and 1, 2, 3, 4, 5, 6 hydrogen in the total formula. Understand? For example, on the whiteboard here, if I substitute one of the hydrogen with the ring, This one is equal to C6H6. If I take one of the H, I substitute with one benzene. The total formula, if you calculate 1, 2, 3, 4 plus 6 is C10 H 1, 2, 3, 4, 5, 6, 7, 8, 9 plus 6, 15. This will be asked in final exam. Okay, we assume we already know this one equal to C6H6, which is equal to this structure. Either one is the same. Yeah. The rest you read. So yeah, the rest you read. So this one also you see in the chart. If you see this one combined with the OH is called penton. You see this one in Panadol. This one chlorobenzene. You see this one in most of the perfume, right? Okay, the rest you read just for your info, right? And there's a lot of name for the ring structure. Okay, we don't expect you to memorize, but at least you see the ring, you know, is under aromatic hydrocarbon. You see carbon structure, and then suddenly there's a ring structure. Is something got smell one, smell good or smell bad? But got smell. Aromatic, means got smell. Okay, okay, the rest you read, it's just info for you guys, right? The rest you read, you read. Yeah. So these are the table. If you want to know what are the scientific name of the ring structure, you can refer to online. There's lots of information about this one. Okay. Okay. For example, name this compound. You see a ring is called benzene. Sure, you need to use the word benzene if you see ring structure. You see Br, Cr, you just go to the table and see what is the name of that one, right? So Br branch is called bromobenzene. If you see Cr is chlorobenzene. You combine these two, is called bromochronobenzene. And the location, you start from the lowest one. You count from number 1 on the top and then clockwise. Okay. In test, I won't ask you. Too easy. Right? You just count clockwise only. Too easy. Huh? All right. So the rest you read. Functional group we already introduced just now. It's just a further information on how you write it in the chain structure. Okay. So in this case, we use R and G. R means hydrocarbon group with the C and H. And suddenly there's a functional group, methane, and so on. So this one you read lah. So you read. So you take methane plus remove the H and combine with OH, will become this structure. Right? C and OH with additional electrovalent outside. So you know that if there's an electrovalent outside, you will change the structure, the shape of the molecule already. Right? So on the left is called non-polar gas. Non-polar means it's balanced. The shape is symmetrical, non-polar. If you get a negative OH combined together, you have an additional electron valence at the oxygen. It's called polar already. Polar means there is a direction of north and south or positive negative side. Means there's a equivalent of electron charges. You can see this 4 dot here on the oxygen. Means the electron can go around the molecule structure. Okay, so this one also inside your handouts. Right, functional group, what does it eat? Okay, alcohol, we're not covered in your syllabus. Right, so I will just stop here lah for alcohol. Okay, so with this we conclude lecture number 8.